Unit 2, Day 1. Recorded on the 25th of August. Alright, complex numbers. So, let's build up to this quickly. This is the part of the lesson that you see like once a year and then never use it any more of the year, and so most people forget some of this stuff. Natural numbers are the positive integers. Sometimes these are called the counting numbers, because they're the numbers you count with. I don't know why they're called natural. They probably occurred first. Like 0 was sort of a later invention. Like they figured out you needed to count things, so we start with 1. And then later on, they're like, well, if you don't have anything, we should put a number on that. Whole numbers. You probably remember this silliness. The whole is what makes it a whole number. 0 and all the natural numbers. Silliness. Integers. You know what integers are. You may not know that we use the fancy Z for integers to represent all the integers, just like we use the fancy R for real numbers. Those are the two most common of the fancy letters we use. If you get into math theory stuff, you can use the others, but most of the time, Z and R will cover what we need to do. Rational number, any number that can be written as a fraction, A over B, where A and B are integers. So it doesn't necessarily mean it is written that way. Like negative 13, that is a rational number, even though it's not a ratio. Right? But it could be a ratio, so it still counts as a rational number. So any terminating decimal, any repeating decimal could be written as a ratio. Irrational numbers, numbers that aren't ratios, and pi and e are probably the most famous, but any of the square roots that don't have a nice square root are also irrational numbers. And then lastly, real numbers, all of the above. Everything is real. Well, all of those are real. But you know from Algebra 2 that real numbers, there's more than just the real numbers. There's also imaginary numbers. And so imaginary numbers came up when someone decided they wanted to solve this problem, x squared equals negative 1. And when you're in Algebra 1 and you try to solve that problem, you're just like, oh, we can't do that. Can't take the square root of a negative number. And we still say that sometimes, like graphing on the last test, like you can't take the square root of a negative number and get a real answer is what we really mean. But they wanted us to have an answer, so they decided, don't forget the plus or minus, that the square root of negative 1 would be I. And so that's just, by definition, we're going to call the square root of negative 1 I, because then we can do a whole lot more algebra with it. A plus bi is a complex number. Standard form is when you write it that way. That's like worth 1 point on the test if you give me the right answer, but it's not in standard form. So be careful. A is the real part. B is the imaginary part. I think that makes sense. If b is 0, then you just have a real number, right? Like it wiped out the imaginary part. If b is not 0, then you've got an imaginary number. And then if a is 0, then we call that a purely imaginary number, because there's no real part to it at all. It's completely imaginary. At the bottom, here's a picture to try to describe all the different types of numbers. Like complex numbers would be 5 plus 2i. Purely imaginary numbers would be the 2i. And then 5 you can put all the way down to, that's a natural number. There's other ways to classify numbers. So if you Google Venn diagram of number classification, you get all kinds of wacky pictures. All right, let's keep moving. What are some real-life uses of complex numbers? So students get this idea that, oh, it's the number's imaginary, therefore it's like just this mathy thing that we just, it's not really any use. But tons of electrical engineering is imaginary numbers. So that's my example. There's an example there that explains some light waves and complex numbers and whatever, but electrical engineering has a ton of I's in it. I located my electrical engineering textbook from 20-something years ago, almost 30 years ago. And you open this up, and almost any page you get to, I is going to be involved. Now, they use J rather than I, so it's hard to recognize it. But there's lots of uses for I. This is not one of those things where, like, oh, that's a math thing, who knows? Like, no. They use I a lot in engineering. All right, there's a pattern with I's. Remember what you learned from Algebra 2 or not. If I is square root of negative 1, then I squared, what would I squared be? That would be negative 1. And I cubed, now rather than going back and rewriting square root of negative 1 times square root of negative 1 times square root of negative 1, just rewrite it as I squared times I. Because I squared is negative 1, so this is negative I. I to the fourth I could write as, I squared times I squared. What's I squared times I squared? I mean, it is I to the fourth, but negative 1 times negative 1 is a positive 1. And then I to the fifth, from here on, I could write them as I to the fourth times something. I to the fourth times something. And that's helpful because I to the fourth is 1. So now we just repeated the pattern. So I to the fifth is I. I to the sixth is I to the fourth times I squared, so 1 times negative 1. I to the fourth times I cubed. 1 times negative I is negative I. And then 1 times 1 is 1. And I'm going to add a line up here to help see the pattern. At the very top there, I to the first is I. And so every fourth term it repeats. I negative 1, negative I 1, I negative 1, negative I 1. And so you keep going like that. So I to the 29th, one way to get there, it would be just to count 1, 2, 3, 4, 5, 6, 7, 8, and then just start over. 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29 is I. Now, that's not awful for 29, but we could rewrite this. If there was a power, or if there was a multiple of 4 as a power, it'd make it a lot easy. So what's a number a little less than 29 that's also a multiple of 4? 28. So I would rewrite that as I to the 28th times I, because I to the 28th is 1, and that just sort of resets my pattern. Rather than counting all the way up, I'm dealing with multiples of 4. So what's a multiple of 4 that's slightly less than 95? Multiple of 4 less than 95 would be 92. That leaves 3 left over. And again, we like the multiple of 4 because that means it's just 1. I cubed is negative I. And then that last one looks kind of crazy. But every 100 is a multiple of 4. So all I really care about is those last 2 digits. So this would be the same as I to the 80 times I to the first, which would just be I. So multiples of 4 are the big deal for I's, as well as knowing the pattern. You got to know the pattern. Now, this is one cheesy way to know the pattern. Kind of don't like it because it's not complete, but if you won the lottery, you'd probably say, I won. I won. Why do I say that that's sort of an incomplete help? It doesn't have the negatives on there. So, I mean, it's not awful, but you recognize it's not everything. It's sort of like when you use soap to factor. It's like, well, it tells you the signs, but doesn't tell you the terms. This tells you the terms, but doesn't tell you the signs. And someone's like, well, could you change it to I negative 1, negative I 1? Well, yeah, but then it's not so catchy anymore. So, I don't know. If that helps, great. If not, whatever. You do need to know the pattern, though. All right. I'm pretty sure you did this in Algebra 2, so we're going to cruise through this relatively quickly. But again, stop me if we need to. What's the square root of negative 81? It is not negative 9. It's 9i. Right? Because the square root of negative 1 is I. And the square root of 81 is 9. So 9i. And that's showing way more work than I hope you need to show once we get rolling on these. Five square root negative 12. Let's see. I'm going to take this negative out as an I. And then how could I rewrite 12 so that a nice square root shows up? 4 and 3. And so the square root of 4 is 2. So 10i root 3. It's another one of those places where how much work you show is up to you, but be careful.
Is this considered for like standard form?
So standard, that's a good question because it does say standard form. Standard form is a plus bi. So those are fine because there's not an a on either one of those. Mm-hmm. And you could write it like that, but it's going to be, someone's going to think that I is in parentheses or in the square root. So it's not wrong, but it better be real clear that it's not part of the square root. You jump the gun because standard form matters on the next one. Negative 10i plus I squared is negative 1. So Bailey gave away the answer to my next question. If I leave that as an answer, I'm going to lose a point. Why is that? Not in standard form. I got to put the real part first, and then the imaginary part. Write your answer in standard form. So that's sort of the last thing you double check to make sure it's real part first and then imaginary.
Attention teachers, that was the ADA bell. Please pay for your ADA attendance at this time. Have a great day.
All right, you see if you can do 4 and 5 in the amount of time it takes me to do the attendance. Remember, you just treat them like any other variable. Look for like terms. All right, attendance is done. Did I beat you, or did you beat me? I wanted you to do 4 and 5 to give myself a chance to win, basically. You still beat me? Good. You should, because you're just combining like terms. 13 minus 5 is 8. Negative 2 plus 6i is plus 4i. 3 minus 6 is negative 3. Careful with the minus signs. Uh, 3 minus 6 is negative 3. 2i minus 13i is negative 11i. Those are in standard form, so we're fine. Like, treat them like regular variables. In fact, you almost always just treat them like any other variable, except when I squared shows up. So on number 6, let's see, distribute 21 minus 35i minus 6i, and then we got to be careful. Negative 2 times negative 5 is positive 10. I times I is I squared. But what becomes of 10i squared? Negative 10. Because I squared is negative 1. So 21 minus 10 is 11. Negative 35 minus 6 is negative 41. Number 7, surely no one is going to tell me that the answer is 25 minus 16. Why is that wrong? I squared the 5 and I squared the negative 4i. I need to FOIL. There's another term in there. So those terms are going to show up, but I need to FOIL to get that middle term. So yeah, there's the 25. Minus 20i makes minus 40i. And then, again, be careful skipping steps. People lose points here because they think they're going to do it all in their head. And sometimes they get it right, but sometimes they mess it up. So plus 16i squared, which is minus 16. So 9 minus 40i. What do you want to do first on number 8? Because if you do number 8 the wrong way, you can get a wrong answer. Let's do the square root things first, because those are exponents. Like, think of order of operations. We know that, or we say that we can multiply the insides of a square root, but don't do that here. Let's fix them first. So 3i, 4i, 12i squared, negative 12. As opposed to, if you multiply the insides of a square root, like we normally think we can, negative 9 times negative 16 is 144, and the square root of that is 12. But you got to do exponents before you do multiplication. So that little trick gets us in trouble when negatives and i's are involved. Right? You know what I'm talking about? Like, square root of 3 times square root of 5. What's that equal to? Now you're scared to answer. Square root of 15. And that's right. But if negatives are involved, things get a little bit weird. So be careful. Make sure you take the exponent before doing the multiplying. Speaking of foiling. You know what? Before we FOIL that, I think I'm going to change that to 2 minus I square root 6. Alright, dividing complex numbers is less intuitive. There's a whole lot of words there. But I will remind you that I is the square root of negative 1. So treat I like you do a square root. Right, however you fix the square roots, I is a square root, so you fix it the same way. Let's remind ourselves how we fix square roots. If we had 3 over 5 square root 7, make it that one. How would you fix that one? What would you multiply by? Top and bottom by square root of 7. So you'd end up with 3 root 7 over 35. What if you had 3 over 5 times 7? Right, the root 7 times root 7 becomes 7. That's why we multiplied by the square root. I wouldn't say what cancels out. The square root signs cancel out. You can say that. Because root 7 times root 7 is 7. And then 7 times 5 is 35. What if you had 3 over 2 plus 5 square root 7? Do you remember how you'd fix that? What would you multiply by? 2 minus 5 square root 7. We're not going to do that because it takes too much time and I don't have space. But it's going to be the same thing when it comes to i's. I is a square root, so treat it like you do all the other square roots. So what do you think we should multiply number 10 by to fix that square root in the bottom? Just the I. I don't need the 5. I don't need the negative. Sure don't need the 3. I is the problem. So we'll multiply top and bottom by I. And again, skipping steps, maybe. Showing work, maybe. I squared is negative 1. So this becomes 3/5 I. Number 11. I think I did it the long way around first in last period. What do you want to do first on number 11? Okay, so like I jumped in with fixing the i's and my brain didn't even see the fact that I could just reduce everything by 2. So I think that would make life a little easier. So let's do that. Then we can multiply top and bottom by I. So 4i. Alright, I'm going to start skipping steps a little bit here. 8i squared is negative 8 over I squared is negative 1. Now that looks a little funny. It's not wrong, but write each answer in standard form. So 8 minus 4i. How about 13? What do you want to multiply by on 13? 2 minus 3i. So the top is easy, 10i. Again, I almost get in trouble when I start to skip these steps. 5i times negative 3i is negative 15i squared, which is plus 15. That's probably poor on my part by not modeling the showing the work step there. And then in the bottom, 2 times 2 is 4. The O and the I of FOIL cancel out because they're conjugates. That's why we multiply by the conjugate to make that stuff cancel out. And then I'm going to slow it down here and not try to do it all in my head. That's going to be negative 9i squared, which is plus 9. So 10i plus 15 over 13. But that's not in standard form, so 15/13 plus 10/13 I.
So it would need to be written as that.
It needs to be split up to be in standard form.
Okay.
Now, I get it. This is completely the same thing, right? 15 plus 10I over 13. Like, why is that not okay? The short answer is I don't know why that's not standard form. The longer answer, I think, has to do with when you get to like actual applications of I in your engineering course in a few years. The real part means something to the problem, and the imaginary part means something to the problem. And so it's super helpful to have it already split up as your answer, because now you can say, oh, well, the 15/13 means this, this, and this, and the 10/13 means this stuff over here. So I think that's why we split them up, is because they sort of have different uses later in life. All right, 14 is kind of the same. Let's skip that one. Well, just tell me what you would multiply by, and then we'll skip it. Yeah, -1 plus 2I, top and bottom. We're going to get some algebra practice on number 15 here. It's a good face. Yeah. Because they're not good. Like, neither one of them, like, individually is okay. And then together, they're also not okay. So, what does it take to add fractions? Common denominator. So I've got options here. I could pursue the common denominator right now, but then I'm going to have to fix it later. I think it would be better to fix them individually and then worry about the common denominator. It's going to be the same either way. I just think it'll be better if I fix them sort of separately from one another. That'll fix the I stuff in the bottom, and then we'll worry about common denominator. So I minus 1 over -1, which is not wrong. I'm going to divide them both by -1 and make it 1 minus I over 1. The over 1 is not necessary, but I know that fractions are coming, so I'm just going to leave it as a fraction, because I know I'm headed that way. And see at the bottom, we got 16. Plus 4i minus 4i goes away, so I'm not writing that down. Minus I squared becomes plus 1, so I got a 17 in the bottom. And then the top, 12 plus 3i. Okay, still not done. All I've done so far is fix the left fraction, fix the right fraction. Now I need a common denominator, but at least it's an easier common denominator to do. 17 minus 17i. Careful with this minus sign, make sure it goes to everybody. Minus 12 minus 3i all over 17. Let's see if we can put it in standard form on the fly here. 17 minus 12 is 5, so 5/17. Negative 17i minus 3i is -20i, so negative 20/17 I. Now, what I will be okay with is if you say 5/17 minus 20/17 I. I'm going to say both of those are standard form. Time flies when you're having fun. Let's skip 16. I think you can even skip 17. What does it take to solve a quadratic if you can't factor? I don't like skipping 17 because I like to sing. X equals negative b plus or minus the square root b squared minus 4ac all over 2a. And you can see there's going to be a negative in there, and so that's going to lead to an I. negative 6 plus or minus square root of negative 4 all over 2. Oh, this one isn't too bad. Negative 6 plus or minus 2i over 2. Negative 3 plus or minus I. But you did that last year, right? You did quadratics with imaginary numbers, I think. So that's a reminder. The next page, last page, but easiest page of the group, although new page, you haven't done this before, I don't think, is graphing complex numbers. So they're not on the xy plane, they're on the complex plane, which is not the xy plane. The good news is it works just like the xy plane, though. So if I want to graph 3 plus 2i, well, the real part is 3, and the imaginary part is 2. So I'm going to go 3 on the real axis and 2 on the imaginary axis, and there's my point. So we make a big deal of saying it's not the xy plane, and people get confused because it works the same way as the xy plane. Negative 4 plus 5i. So negative 4 on the real axis, plus 5 on the imaginary axis. There's point B. What about point C? 5i. Where's that going to go? Up, down, left, or right? Right. There is no real part of that, so it's just going to go up 5 to land on the imaginary axis. Almost said y-axis. So that's pretty easy to graph points. 5 minutes to spare. Worksheet 1 is the assignment. I'll pass